So let's take a look at this model that we saw back in 1.5, forces in motion, and also at the end of our cycle test. Okay, understanding this model will really help you understand the concepts of model 2. If you didn't understand this model, you're probably struggling with the concepts in chapter 2. Okay, so I want to go over this. The way to read this model is you are reading from left to right and you're reading row by row. Okay, so let's take a look at this first row. You have to understand what these symbols are. So this is object A, is supposed to represent pod A. These are the different velocities in 3 different levels, and these are the different forces in 3 different levels and 3 different, and in 2 different directions each. Velocity, same. So pod, in this before force, pod A is moving to the right. I know this because we have talked about velocity lines are always behind the motion. So let's take a look at the velocity, the speed and the velocity. That speed is a medium. And it's moving to the right. A force is exerted on it, a very tiny force, a small force, and it's going to the left, the opposite direction. And now we have our pod A change velocity, and it changed to slow down. So it's at a slow level of velocity, and it's still moving to the right. Okay, so the velocity change is a slowdown. Let's take a look at the second row. For the second row, pod A moving at a medium to the right. A little bit, so a medium force is exerted on object A, and it's moving to the left, opposite direction, and it comes to a stop. The reason I know this is a stop is there's no velocity lines, it's at rest. So the velocity change of the second row is a stop. Okay, remember our 5 changes in motion or 5 velocity changes are to stop, to slow down, to speed up, to start, and to change direction. 4 S's, and that's C. Okay, let's move on to our last row. So our last row, again, we started off at medium velocity, and the object A is moving to the right. A large force now is exerted on object A in the opposite direction. And over here, we see that there's a change in direction and a slowdown. Slow and change in direction. Whenever you have a change in direction, you're always going to have a slowdown. Think about your experiences in cars. When the car is turning, you are automatically trying to slow down. Okay, change in direction. So you need to understand these 3 levels of changes in motion. Okay, so which velocity change needs the most force exerted? The change in direction. Which velocity change needs the least amount of force exerted? The slowdown. And the one in between is the stop. Okay, and these 3 relate to our claims. Okay, so our claims that we've had all module is that claim 1 is saying that the thrusters, when they turned on, there was a change in direction. And in claim 2 was saying that the thrusters, when they turned on, the pod slowed down. And then normal pods, when the thrusters turn on, they stop. I hope this explanation helps you understand this model and helps you connect the pieces of our module mystery.